Hello everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. The subject for the video lecture we selected probability and statistics. The topic what we are going to discuss is fit binomial and Poisson distributions. In detail what we are going to discuss: definition of binomial distribution. Next, a definition of Poisson distribution. Next, we are going to do the problems concerning about fit your binomial distribution and how to fit a Poisson distribution. These are the main 4 subtopics we are going to discuss in this video lecture: fit binomial and Poisson distributions. The definition of binomial distribution: a random variable, capital X, that is random variable which is always denoted by capital letters. That is the variable, what is the condition which is given in the problem, satisfying on where we are going to apply it on the sample space, and the output will be coming as in terms of real numbers. That is the reason this capital X, we will call it as a real valued function. So the random variable, that is X from S to R. S denotes sample space and capital R denotes real numbers. So the distribution is binomial distribution. That is the outcome, whether the possibility or the satisfying the condition, the result will be either success or failure, true or false, or yes or no. The output based on this it will be. If it assumes only non-negative values and its probability density function, which is given by P of capital X equal to R, which is nothing but P of R. So NCR, P power R, Q power N minus R. This R takes a value from 0 to N. Yes, we are able to count finite. P represents probability of success. That is, what is the condition which is given? We are accepting that given condition satisfaction, that is probability of success. If we are not getting, that is failure, that is probability of failure, which is denoted by small q. So what are the notations which are dominating in the formulae? That is NCR, P power R, Q power N minus R. In this, the P represents probability of success, Q represents probability of failures, and N represent number of trials. In this video lecture, we are going to use the binomial distribution formulae, and usually in every textbook also this is the notation which is used. That is the previous slide we have taken R, that is, but here we are using X. Even we are going to do all the problems using this notation, that is NCX, P power X, Q power N minus X. This is very, very important point. That is, X is taking the value from 0 to N. This is the difference which makes between binomial and Poisson distribution. So we can see here in the rough column, which is 0, 1, 2, 3, 4, 5, 6. 0 to 6, it's finite. We are able to count and we are telling N is 6. Whereas here, it is taking 0 to 6. It goes on because here the dot dot it represents, it goes up to infinity. This condition which comes under binomial distribution, whereas this comes under Poisson distribution. This is a very easy way we can understand the concept between binomial and Poisson distribution. So the definition of Poisson distribution: a random variable, capital X, is said to follow a Poisson distribution if it assumes only non-negative values and its probability density function, which is given by probability of x equal to x, that is p of x, e power minus lambda into lambda power x divided by x factorial. Here the x is taking the value 0, 1, 2, 3, so on. But the previous what we discussed, the binomial distribution, that is 0, 1, 2, 3 up to n. This point only the students they have to understand very clear the picture about Poisson and binomial. This lambda value always positive. That's what the mathematically we denoted. Lambda greater than 0. This is the parameter. That is lambda, it's nothing but mean. That is mean of the Poisson distribution is lambda. Yes, now we will come to this video lecture, the topic, fit your binomial distribution to the following data. X, the data which is given 0, 1, 2, 3, 4, 5. When x equal to 0, f is given 2, 1, 14, 2, 20, 3, 34, 4, 22, 5, 8. How to move, how to solve this problem? First, in the lower classes we studied, because the binomial distribution is there, we need your probability of success, P, the value which is not given, Q, failure, that is also not given. Only the thing from the question we can, from the data, 0 to 5 is there. So the 5 represents n, small n. We know the binomial, the formula is ncx p power x q power n minus x. To substitute, we need p and q. But those data which are not given in the question. So we are taking the earlier, the classes what we studied, very familiar, the formula, mean equal to summation fx by summation f. So the x, the data which is given, the question horizontally which is put, we are listing vertically, x which is listed vertically, and the frequency also totally 6 data are there from 0 to 5, 0 also included. So 6 data and f we have kept it fx. So this both we are going to multiply. So 0 into 2, 0, 1 into 14, 14, 2 into 20, 40, 3 into 34, 102, 4 into 22, 88, 5 into 8, 40. So we are adding summation f equal to 100 and summation fx, the symbol summation, is 284. Why we have to do? The main thing is we need what is P. So to find P, the mean of the binomial distribution, the formula is NP. In this we know only n from our given question. We don't know what is the value of P. So from the mean, this simple formula, with the help of that, we got the value summation fx. We obtained the value 284 divided by 100, which is equal to 2.84. This summation f, we can note it, the notation is capital N. So we can say it that the star x completely, the next f completely we have added, we got the result 100, and fx completely we added, we got it 284. Mean value is 2.84. So this is the formula. Now NP, so we obtained the value 2.84. From which n value we are substituting, that is 5. So P is nothing but 2.84 divided by 5, which is equal to 0.568. If we know P, easily we can find Q, because probability of success plus probability of failure, which is equal to 1. Always the total probability is 1. That is P plus Q equal to 1. Using this, we are finding the value of Q. So the Q we obtained 0.432. The formula to fit a binomial distribution is n of Q plus P the whole power n. We know it, what is capital N? It's nothing but summation F. Q value is 0.432 and P value 0.568. This small n represents number of times, that is 5. So we are substituting the datas. N is taking the value of 100, Q 0.432 and P is 0.568 and is 5. We did the binomial expansion. It's a very, actually here the space concern it is written. We can write it continuously like this. So 5C0. Here this is first one, 0.432 power 5 and 0.568 power 0. Next C0, C1, C2, C3, C4, C5. We can notice it very easily. That is 5, this power it goes on decreasing, whereas the next term it goes on increasing. If we do any careless mistakes, easily we can point out ourselves and we can correct ourselves. Now this 5C0, the value, very simple one, 5 factorial divided by 0 factorial. This both we have to, so the value is 1. So the corresponding the values, similarly 5C1, 5, 5C2, the values we are going to substitute. 0.432 the whole power 5 value. A power 0 the value is 1. So using the calculator, easily we can calculate the corresponding the places. They are replaced by their own values. Yeah. So the 100 we have done it. The first one here is there. Simplifying, we obtained 0.0150. The second one, we obtained 0.0989. The next one, 0.2601. The next one, 0.3420. So we can see it 1 minute. Two, 4, 6. Here also 2, 4, 6. So the corresponding the values are taken. Now, the next step, we are taking this 100 inside. So 0.0150, it has become 1.5. This it has become 9.89. This it has become 26. This 34 and 22.4. The last one is 5.9. That is each the number, the term values are multiplied by 100. We obtained, this is the result. So this is our question. x, the value f, which is given the data of our question. They expected the frequency. Now this 1.5, we can write it 2. It's a round off. Then 9.89 we have taken as 10, 26 as it is, 34 as it is. This 22.4, because 5 above 5 we will do the round off. Here it's only 22.4, so it is 22. 5.9, that is 6. So this is the question, x frequency. So using the formula n of q plus p the whole power n, we obtained the expected frequency. Initially, with this, we started the problem for the solution. This is the formula we have taken. We obtained this result. So the first problem we completed. Different type of the second problem regarding binomial distribution we can concentrate. Here it is kept p plus q equal to 1. That is, the p represents probability of success, q represents probability of failure, which is equal to 1. Now here 4 coins are tossed 160 times. Simultaneously we are tossing. We are not giving a gap. That is tossing one coin, giving a gap, space of time, another coin. No, it is not. 4 coins are tossed at a time. How many times? 160 times. That means n is given. The number of times x heads occur is given below. This is the condition which is in this particular problem which is given. X data which is given 0, 1, 2, 3, 4. And number of times. So when x equal to 0, 8 times, 1, 34 times, 2, 69, 3, 43, 4, 6 times. Fit your binomial distribution to this data. On the hypothesis that the coins are unbiased. So now, we are getting probability of success and probability of failure. The two possibilities only. Always a binomial distribution, it based on yes or no, true or false, success or failure. The outcome will be based on this only. Now suppose the coin, one coin is there. In general thing, if you toss, the possibility is that head or tail. Head occur, then the basic definition of probability is what is the condition which is given in our problem satisfying that how many outcome? Only one. Total outcome, it's head and tail, 2. This is the basic definition of probability. Getting heads, why it is written? Why it is not written tail? Because the question is head. That's what the satisfying the question condition we have written, getting heads. Suppose in our problem here tail is there, we will be writing getting tails. Q. It's very easy one. If you obtained the probability of success, then it is very easy to go about finding Q. That is the probability of failure. Q is nothing but 1 minus P. This we obtained from this. So 1 minus P is nothing but 1 minus 1 by 2 equal to 1 by 2. Number of heads, we know it, the binomial distribution formula. NCX P power X Q power N minus X. Where this N is taking the value from 0 to N. Ours is 0 to 4. That is what here it is written, 4. So the binomial distribution formula we have written here. Yeah. So P of X equal to X, NCX P power X Q power N minus X. So now when x is taking the value 0, this particular formula we are going to substitute. N, it's 4. P is 1 by 2. Q also 1 by 2. X, how many places x is dominating in the formula? 3 places. 1, 2, 3. So the 3 places x is replaced by 0. So 1, 2, 3. So the particular places the values are replaced. Then we obtained here a power 0, the value is 1. Here also 1 by 2 the whole power 4, the value is 1 by 2 power 4. 4c naught, the value is 1. We obtained when x equal to 0, what is the probability? 1 by 16. Similar way, we have to do it when x equal to 1, 2, 3, 4. Because up to 4 only our given problem data is. So when x equal to 1, the same n, p, q, there is no change at all when we are comparing with the previous step. Where the changes are going to occur between the before step and this step? Only in the place of x. 1, 2, 3. This point, if you concentrate, we can avoid lots of careless mistake. So x, 3 places, 1 is dominating because we are concentrating, we are focusing now what is x. X is taking the value 1. So 4c1 is 4. 1 by 2 power 1, 1 by 2. Here 1 by 2 power 3, it's 1 by 8, and we simplified it. We obtained the result 1 by 4. The next, the similarly we have to do when x equal to 2. So easily we are picking, yes, the 3 places x is there. X is replaced by 2. Remaining the values p and q, 1 by 2, n is 4. So we simplified it. We obtained 3 by 8. We are continuing the step when x equal to 3. The similar way the x is replaced by the value 3. We obtained 1 by 4. The last one, when x equal to 4. When x equal to 4, 1, 2, 3. The 3 places x, which is replaced by the value what we have taken 4. P and Q, the same 1 by 2, and n is 4. The probability when x equal to 4, the result what we obtained, 1 by 16. So we have to, while solving these problems, we have taken the 4 point, the star. If you are noticing, x equal to 0, x we changed it, and 1. So it is 3 places, 1 is changed. Then we moved to 2. 3 places, we changed the x value 2. The similar way, the next step also x value 3. The last step, x value is 4. We obtained from 0 to 4 the probability distribution using the binomial distribution formula. Yeah, just we are keeping in the rough what are the values we obtained it. So now we are going to construct the table fit binomial distribution. So we constructed, and the first column is x, the second column is number of times. These data, the first 2 columns data which are given in the question itself, the probability p of x, that we kept it in the rough column, that we are going to put it. That is the previous step, previous slide. What we discussed, these values are put it here. Expected frequency, f of x equal to n into p of x. 0, 8, that given data. So the probability of 0, we obtained 1 by 16, that we kept it here. They expected the frequency, the formula n into p of x. N, capital N. How many times the 4 coins are tossed? 160 times. That is a condition which is given in our question. Into p of x. That is p of 0. We are concentrating now x equal to 0. That 160 divided by 16, it's nothing but 10. The next one is 1 and 34. P of 1, the value is probability of x equal to 1 is 1 by 4. So the 1 by 4 which is multiplied by our 4 coins tossed to 160, we obtained the result 40. The next one, 2 and 69. So the probability of 2 is 3 by 8, that we substituted. So 160 into 3 by 8 equal to 60. So next 3, it is 43. So P of 3 equal to 1 by 4. So 160 into 1 by 4, the result is 40. So the last one is 4, 6. So P of 4 equal to 1 by 16. So the 1 by 16 which is multiplied by 4 coins which are tossed 160 times, satisfying this formula n into p of x, n into probability of x, which is taking the value from 0 to 4. The last, when x equal to 4, we obtained the expected frequency after multiplying this. When x equal to 4, the probability is 1 by 16, which is multiplied by 160. Then the final result is 10. So very simple task, we have done it. That is, x is given, number of times the data is given. Using the binomial distribution formula, we obtained all the probabilities. Then n into p of x, using that expected frequency we obtained. So we can see it here. This is when x equal to 0, 1, 2, 3, 4. So we can see the here simple step what we have done it. Easily we can see it here. That is a star point, it is there. Yeah, we can see it 1 minute. 0 and 8 is there. Yeah, it's somewhat it is the seconds it is kept. Oh yeah, minute, 1 minute. Yeah, we can see it here. Yeah, first we are concentrated. What we have done it 0, 8, P of 0, 8 we are focusing, and we moved to P of 0, we obtained it. Then that what we have done it 160 which is multiplied by the complete 1 by 16, we obtained the result 10. The similar way 1, 2, 3, 4 for the x values are done. Yeah, the next problem, one more problem. The third one, using the same binomial distribution, we will concentrate it. Fit your binomial distribution to the following frequency distribution. So x is here, it's given 0, 1, 2, 3, 4, 5, 6. F, when x equal to 0, it's 13, 1, 25, 2, 52, 3, 58, 4, 32, 5, 16. When x equal to 6, the final f is 4. So n equal to number of trials, 6, the data. Here only mostly the students actually, here also we are finding the careless mistake. The concept behind is the binomial distribution, x is taking the value from 0 to n. So 0 to our given problem, the last, the data 6. So the number of trials 6. So now horizontally the data which are given, we listed vertically in the solution. X 0 to 6 and F, the data are listed, and we did the multiplication fx. Why we have to do it? Because to move, we don't know what is P. If P we know, probability of success, because the formula NCX P power X Q power N minus X, we know only N. We don't know what is P. We don't know what is Q. If we know P, with the help of P, we can easily find Q because the total probability is 1. We are taking this mean formulae, summation fx by summation f. So we added summation f 200, summation fx 535. We substituted in the formula. So 535 divided by 200, we obtained 2.675. So completely, this full complete, the star which is representing, we focused complete the frequency of data, we obtained this 200. Then we moved to the multiplication, this for which we multiplied. Again the complete data we have taken, we obtained 535. That's what the star which denotes. So the mean of the binomial distribution is NP. So we have written, so NP we obtained 2.675. So the N is which is replaced by 6, 6 into P equal to 2.675. P we obtained 0.446. P we got it, it is very easy, from which we can get Q equal to 1 minus P. So the particular P value is 0.446. We subtracted from 1, we obtained the Q value 0.554. So the formula to fit a binomial distribution is n of Q plus P the whole power n. So our capital N is 200. So P is 554 and Q is 0.446. Sorry, P is 0.446 and Q is 0.554. So we substituted, we expanded the binomial expansion. So we can write it horizontally. This presentation purpose, adjustment purpose, it is kept one by one. But one by one writing, easily we can identify where we have done it any careless mistake or not. First we can focus on this 6C0, next 6C1, 6C2, 6C3, 4, 5, 6. This term starts from 6, this term 0. That is this number 0, you can see it. Then it goes on, the power decreases. Here the power goes on, increases. Then easy to write the formulae, the binomial expansion. Yeah, here we can 200 of this. This is capital N, that is summation F. This is our equation. Adding, we obtained that 200. 6C0, the value is 1. 0.554 the whole power 6. Using the calculator easily we can obtain. This value, no need of calculator at all. A power 0, the formula, which is always 1. So this particular thing we obtained 0.02891. For this 0.1396. For this 0.2809. Similarly, all the values we obtained it. So the last one is 0.007866. Now this each value which is multiplied by 200. So multiplying the first one 5.782, second one 27.92, third one 56.18, the next 60.32, 36.42, 11.728, 1.5732. 5 above 5, we did the round off. So this is becoming 5.7, it has become 6. 27.9, which has become 28. This is 56.1, so it is 56. 60.3 is 60. 36.4, 36. Whereas 11.7, that is 12. And 1.5, that is 2. So this is our equation which is given in our problem. So the expected frequency. So we obtained 6, 28, 56, 60, 36, 12 and 8. So the next problem we can concentrate the distribution of typing mistakes committed by a typist which is given below, assuming the distribution to be Poisson. So now we will concentrate our focus on Poisson distribution out of it. Find the expected frequencies. This is the frequencies which are given 0, 1, 2, 3, 4, 5. Whereas when x equal to 0, the frequency is 42. When it is 1, 33, 14, 6, 4, 1. The mean of the Poisson distribution, whereas binomial, mean of the binomial distribution is NP, whereas Poisson, it is lambda. Same as it is, we listed, we have written the given data vertically, x under 0 to 5, f under all the data written, fx we are finding, summation f. Here also we want the Poisson distribution formula is e power minus lambda, lambda power x by x factorial is the Poisson formula. To this formula, we must know what is the value of lambda. But the value of lambda which is not given in the question. That is the reason these steps are done while solving the problem. To approach the value of lambda purpose, these steps are done. So summation f is nothing but capital N. The mean formula, summation fx by summation f. So 100 divided by 100, which is 1. So we can see it completely. We have taken f 42, 33, 14, 6, 4, 1. We added, we obtained this one. Next, we are moving to fx. So we can see it, that is 0 into 42, 0. 1 into 33, 33, 2 into 14, 28. Similarly, other data is also done and we obtained the particular summation fx is 100. So this is the Poisson distribution formula, e power minus lambda into lambda power x by x factorial. So x equal to 0. So here it's very easy how many places our changes are going to come. 2 places x is there, whereas binomial distribution 3 places x are there. It is these are the thing not related to mathematics. Some sort of technique to avoid the careless mistakes. We can do the comparison between the formulae. That is binomial distribution 3 places x are there. NCX, p power x, q power n minus x. Whereas Poisson, e power minus lambda, lambda power x by x factorial, 2 places. So when x equal to 0, the 2 places, the x to be replaced, 0 to be written. A power 0 and 0 factorial, both of the values are 1, e power minus 1, we got it. When x equal to 1, similarly, the x which is replaced by 1, we obtained e power minus 1. X equal to 2, we replaced it, we obtained e power minus 1 by 2. X equal to 3, same, similarly we have done it. So 3 by 3 factorial, we obtained e power minus 1 by 6. When x equal to 4, we obtained e power minus 1 by 24. The last data when x equal to 5, so we obtained e power minus 1 by 120. So we can see it. What are the steps actually we followed it? The given data 0 to 5. So first 0, x equal to 1, x equal to 2, 3, 4, 5. And we are focused on x only. The star mark denotes that where the x's are there, we are changing according to the x value. So just we kept it in the rough. What are the values we obtained it? We will construct the fit Poisson distribution. So this is our question data. So the first is 0 and 42. So when x equal to 0, what is the probability we obtained? So we kept it in the rough. That is e power minus 1. That is substituted. Fit your Poisson, that is n into p of x. It's nothing but f of x. So 100 into, when x equal to 0, the probability is e power minus 1. Using the calculator, the value we can obtain. Then that is multiplied by 100, we obtain 36.76. Now similarly, now we have done 0, when x equal to 0, the frequency is 42. We obtained f of x is, that is f of 0 is 36.78. Similarly, we have to do now 1 and 33. So when 1 and 33, here the probability of 1 is e power minus 1. That is written. F of 1, it's nothing but what is the p of 1, which is multiplied by 100. This 100, how we obtained? This completely we added summation f, that only capital N. So the second, when x equal to p of 1, for which f of 1 is 36.78. So similar the same, the treatment we can give when x equal to 2, that is the frequency is 14. So the p of 2, we obtained e power minus 1 by 2. Then f of 2 is nothing but p of 2, the result, which is multiplied by 100. We got it 18.39. So when it is 3 and 6, the probability of 3 when x equal to 3, e power minus 1 by 6, and f of 3 is 6.13. So if it is 4, so the p of 4, it's nothing but e power minus 1 by 24. So what about f of 4? F of 4, it's nothing but p of 4, which is multiplied by 100. So we obtained the result 1.53. So the last one, the final step, when x equal to 5, the frequency is 1, the probability of 5 is e power minus 1 by 120. So for which f of 3 is 0.306. So the fit Poisson distribution. So here we can see it. This how we obtained this results. 36.78. Round off. 36.7. It is written 37. 36.78. 37. 18.3. 18. 6.13. 6. 1.5. 5 above 5 we will do. We will consider 2. 0.3. It is less than 0.5. That is the reason it is 0. This point to be noted carefully. So what actually this Poisson distribution? The initial formula, which is very, very important. 0, 42. P of 0 we did. And we focused it 0, 42. P of 0 we did. That is multiplied by 100. 36.78. And we did approximately 37. That's what the star which denotes. So we have to give the frequencies always integers. So the nearest point we have done it. 37, 37, 18, 6, 2, 0. So the next one is fit your Poisson distribution to the following data. When x equal to 0, 1, 2, 3, 4, 5, the frequency which is given 142, 156, 69, 27, 5 and 1. So the mean of the Poisson distribution is lambda. So what is that? The data which are written horizontally. We have written vertically x and f, and we did the multiplication. Summation f is nothing but addition of all the data which are under f. We obtained 400, and summation fx completely we added. We obtained 400. The summation f, the notation is capital N. So the mean equal to summation fx by summation f. So the 400 divided by 400 equal to 1. These steps why to do? The reason is to substitute in the binomial distribution formula e power minus lambda, lambda power x divided by x factorial. We don't know the value of lambda. To find, to obtain, to get the value of lambda, these are the steps are followed. So we can see this, the star mark, what it denotes completely. F we added, we obtained, then it tells us fx we completely added, and we obtained the results. So this is the Poisson distribution formula. So P of x, e power minus lambda, lambda power x by x factorial. So when x equal to 0, so we know very well now The Poisson distribution formula, x is dominating two places. Now x is 0, so it is replaced. We replaced it in the particular x places, zeros. So we obtained e power minus 1. So then what about next? We have to move to 1. So for 1, we replaced it, x as 1. So the numerator 1, whereas the denominator is x factorial. So 1 factorial, the finally e power minus 1, we got it. So the similar way we have to do probability of x equal to 2. We obtained e power minus 1 by 2. And p of x equal to 3. We obtained e power minus 1 by 6. And p of x equal to 4. E power minus 1 by 24. So p of x equal to 5. E power minus 1 by 120. So now this star mark, what it denotes in the slide, that is, first we must know the Poisson formula, x equal to 1, 2, 3, 4, 5. We did. Then we are focusing, where is x? Focusing on x to avoid the careless mistake. That's what the star denotes. Yeah, we have done it correctly and we obtained all the probabilities from x is taking the value from 0 to 5. We got the values. Now we have to focus on construction. So just we have kept what are the values we obtained in the rough, we kept it. So we are focusing on the construction of it, yeah, Poisson distribution table. So the headings, we kept it. This is our question. When x equal to 0, the frequency is 142. The probability, when x equal to 0, we obtained e power minus 1. So f of 0, that is f of x. When x equal to 0, it is f of 0. F of 0, that is p of 0, the value which is multiplied by capital N. Our capital N, it's nothing but adding all these frequencies. That is our summation f is nothing but 400. So now, second one. When x equal to 1, the frequency is 156. Then probability of 1 is e power minus 1. Then what about f of 1? That is the p of 1, the value which is multiplied by our capital N. The result we obtained 147.15. The next one is 2 and 69. So the p of 2, it's nothing but e power minus 1 by 2. What about f of 2? Similar way, very easy now. So the p of 2, when x equal to 2, the probability of when x equal to 2, the value is e power minus 1 by 2, which is multiplied by 400. We obtained 73.58. The similar way we can do for 3 and 27, we obtain 24.53. The next 4, when x equal to 4, and the frequency f equal to 5. P of 4 is e power minus 1 by 24. F of 4, this value which is multiplied by 400, we obtain 6.13. The step, when x equal to 5, f equal to 1, that is p of 5, which is e power minus 1 by 120, that is complete thing which is multiplied by 400, we obtain 1.23. So this is because we have to give a nearest integer. Here we can see 1 147.15. It's round off. 147. This is also 147. Here 73.5. That's what it is, 74. This is 24.5. It is 25. 6.1. So 6. 1.2. It is only 1. So we can see what this star mark which denotes of this particular slide. We are focusing on Poisson formula. The first data we are focusing, and 0, P of 0, for which f of 0, e power minus 1, which is multiplied by 400, 147.15. We round up and we got it 147. So this is the expected frequencies: 147, 147, 74, 25, 6 and 1. So the next problem, fit a Poisson distribution to the following data. When x equal to 0, 1, 2, 3, 4, frequency 109, 65, 22, 3 and 1. Solution. The mean of Poisson distribution, which is equal to lambda. So horizontally, which is given, vertically we have written here. That is when 0 to 4, and here 109, 65, 22, 3, 1. What is the given data? We listed, we have written vertically. And fx 0 into 109, 0. Completely multiplication is done. Summation f is 200. Summation fx, it's 122. Mean formula, summation fx by summation f. We substituted in the particular places. 122 divided by 200, we obtained 0.61. So we are seeing the star marks, what it denotes. That is completely full data we added. 200 we got it. We are multiplied first fx and we are adding. We obtained 122. So the Poisson distribution formula, now we are very much familiar. E power minus lambda into lambda power x by x factorial. Here, so the animation we can see it. So when x equal to 0, so x which is taking the value, the two places, x factorial, that is replaced 0, 0.61, that is a lambda value, which is we replaced a lambda place, its value 0.61. We obtained when x equal to 0, e power minus 0.61. Next, when x equal to 1, that is here the places, that is replaced, we obtained, this is the value. When x equal to 2, we obtained e power minus 0.61. This is lambda 0.61. This is lambda power x. Our x is 2. So p of x equal to 3. Then e power minus 0.61 into 0.61, the whole power 3 divided by 3 factorial, that is 6. Then p equal to x equal to 4. So we can see it here. The final thing we obtained, we got it, e power minus 0.61 into 0.61, the whole power 4 divided by 24. So we can see very clearly 0, 1, 2, 3, 4, and particularly the star denotes x places we are changing. Now lambda completely changed its value 0.61. That's what we have discussed about this slide, that the star mark denotes. So now the final stage of this towards the solution of this problem, we are going to construction part is left over, so that we are constructing the table. Yes, the first data, that is 0, 109, that is P of 0. When x equal to 0, the probability is e power minus 0.61. When it is f of 0, that is P of 0, which is multiplied by 200. That is our capital N is 200. We obtained 108.67. The next data is when x equal to 1, then the frequency is 65. We obtained the previous slide what we discussed. The probability of x equal to 1 is, this is the value, which is multiplied by capital N, that is summation f. We obtained f of 1, that is 66.29. Similar way, 2 and 22, that is P of 2, this is the value, that is e power minus 0.61 into 0.61, the whole square divided by 2, which is multiplied by 200. We obtain 20.22. So for 3, the frequency also 3. So this is the value we obtained, e power minus 0.61 into 0.61, the whole cube divided by 6, which is multiplied by 200. We obtained 4.11. When x equal to 4, the frequency is 1. So we can e power minus 0.61 into 0.61, the whole power 4 divided by 24. So we can see it here, which is multiplied by 200. So 0.63. So finally we can see this, what we discussed, that 4-point star, it tells 0, 109. We are focused, f of 0, that is P of 0, which is multiplied by 200, and lambda we have to focus. So now 109, 66, 24, 1. So we can see it here, this 109, 108.6, that approximately we have taken 109. 66.2 is 66. And 20.2, 20, remaining 4.1 is 4, 0.6, that is 1. That's what here we can see the changes. It is written here. Yeah, we will come to a conclusion of this topic, fit, binomial and Poisson distributions. What is the definition of binomial and Poisson distribution we discussed? Binomial, the problem based on yes or no, success or failure, true or false, NCX, P power x, Q power n minus x, where x is taking the value from 0 to n, whereas Poisson, x is taking the value 0 to infinity or for large values. That difference between the definitions, we must know it. Poisson, the formula is e power minus lambda, lambda power x by x factorial. And we focused the fit, that is first probability of what is the x values from 0 to 5 or 0 to 4, nearly more than 5 problems we discussed it. Then f of x we found, n into capital N, it's nothing but summation f multiplied by probabilities, concerned probabilities. So the first we can see it here. So this is the question 1. First we discussed for which we constructed this table. The next, the second one, that is also we discussed binomial distribution, for which this is the table we constructed. The next one, the third problem also, we focused on binomial. For this problem, this is the table we constructed. Next, we moved to, we can see it? Yes, we moved to Poisson. For the Poisson, this is the table we constructed. Next, the question 5. This is also Poisson, for which this is the table we constructed. The last one is Poisson, for which, yes, this is the table we constructed. Here the lambda value is 0.61. Yes, totally 6 problems we have done it. Binomial and Poisson. Yeah, I'm requesting the students, this video especially, which is done, it's not the video watching. This is teaching and learning processing video. So it's not just instead of watching, just take the note and pen along with the video on, start doing. Definitely after the video is over, you will be getting complete satisfaction. Thank you very much to you all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.